All right, welcome back, people. I think this is video 5. We're almost there. We're almost home. Okay, we finished all the cubic mobility shifts. We deleted the columns 1, 3, 5, 7. We saved it as a text. Opened it in ShapeFinder. There's 4 columns of data. There's 4 channels of electropherograms on our viewer. Okay. Next steps. Consult the protocol. Okay. Perform a signal decay. Yeah, okay. I missed a step. Sorry. We should save this as a shape file. So file, save as. We'll call this step 14. Save format, shape. Save. And, let's also save it as a text file. Okay. Good, Quinn. Following directions of the protocol. This is good. Okay. Sorry. Perform a signal decay correction. That is easy, guys. This is easy money. Got this in the bag. Signal decay correction. On this tool inspector on the right here, signal decay correction, good. Region of interest, okay. So now, what ShapeFinder is going to do is we are going to basically make all of these peaks on an even playing field, okay? So we're only going to want to select data that we know has good peaks, right? So here, the magnitude is massive, okay? But these signals have decayed. That's why they're getting smaller and smaller and smaller and smaller and less distinct. Well, that's why we use the signal decay correction tool. I know, I was just as amazed to find that out, that the naming is just so on point. All right, let's find a good region of interest. That's the next point of matter, point of origin. Okay, so we are going to start probably after these big peaks, okay? We're going to start, I would say, I like finding this region right here. You get these big peaks, and then you kind of die off a little bit, have a little hump, and then you start. I feel like that is the start of some good data. This is arguably some peaks as well. And you'll get really close to the primer if you do this. But I think this is a healthy place to start. So we're going to select here and drag. Click and hold and drag and drag and drag and drag and drag. Actually, let's stop, guys. Stop. I messed up. We are going to remember that we're going to start at 1700. Now what we're going to need to do is scale it back up so we can see the decayed signals at the end and where we're going to stop. Now the question is, well, Quinn, what's a good stopping point? Answer is when the signals start to go a little bit hairy. Right here, 3400 to 3500, this is a bad, like the green is starting to get bad. Up until then, it's pretty good. You got some peaks right around there. So we'll stop right, let's stop it right here. That's a good point. So we'll go here, drag back to the region that we started at, which was like 1700. We both saw that point. So we're going to keep dragging. Okay, right around 1700. This is where we need to go. Okay. So as you can see, when I selected that, it populates the region of interest. Rescale factor, this will stay the same. All of this up here will stay the same. Apply to channel 1. There's 3 values we need to remember for this. 1,000,000 for A. That's 1 with 6 zeros. 0.99 for Q, 3 nines. And C is 10,000, okay? That is 4 zeros. And you'll see why I say that. So we're going to hit append. Holy smokes, something happened to channel 1. Well, it got corrected, okay? These values changed. That's all right. Now we're going to select apply to channel 2. For A, we're going to enter 1,000,000 again. 1 and then 6 zeros. 1, 2, 3, 4, 5, 6. Q, 0.123, 3 nines. C is 10,000, 1 with 4 zeros, 1, 2, 3, 4. Append. Okay, channel 2 changed. Channel 3, make sure to click that, million, 6 zeros, 1, 2, 3, 4, 5, 6. Q, 3 nines, 1, 2, 3. C is 10,000, that's 4 zeros, 1, 2, 3, 4. Append, excellent. Now channel 4, a million, 1, 2, 3, 4, 5, 6. 3 nines, 0.999. C is 10,001, 1, 2, 3, 4. Append. Okay, now we're done with the signal decay correction. Now we're going to do a scale factor. Apply a scale factor. Go to Tool Inspector, and you can see in the script that there's 4 signal decay corrections for each of the 4 channels. So scale factor, it's already like pre-programmed. It couldn't get any like nicer to us. The scale factor that we're going to want to use for channel 2 only is in between 0.4 and 0.7. To better visualize this, we need to select channel attributes, right? Only select channel 1 and 2. All right, this is why we do a scale factor, guys. So there's going to be regions of modification, we know that, A, and B, there's going to be regions of no modification. Okay, that's completely normal, right? So what we need to do is scale the green, the height of the green electropherogram down to the blue electropherogram for regions of data that have no modification. And your question is, well, how do you determine what areas of the blue electropherogram have no modification? The answer is the height of their peaks. So right here, I'm going to select this region. This right here is no modification. The blue peaks are very low. Compared to its neighbor to the east, these peaks are probably modifications because they're higher, right? Same right here. Like, look, this little region, no modifications there. No modifications here, and probably no modifications here either. Maybe a couple, right? So we're going to scale this down. And what we're looking for is for in those regions that I kind of just identified, the low blue, like this is going to be the focal point of this step, this highlighted region, right? When we apply this, we're going to make sure that this green data gets to the height, shrinks down to the height of the blue data. So we're going to go over here. I'm fine with starting with 0.4. We'll append it and see where it goes. So watch, the green right here where I have my cursor, or the little tick marker in the viewer, the green is going to shift down. So I'm going to hit append. And it does. So holy cow, it is like right at very similar heights. So this is good. This is scaling the control lane to no modification where there's no modification, right? So this is reflecting the scale, the height, normalizing it all down to a common region. You're controlling the analysis with this step. You can check other parts of the equation, of the electropherogram out. Right there's good. Right there is pretty good. Right there it's a little bit lower, but that's okay. We want to error on the side of the green being lower than the blue, and that is for normalization purposes. So the entirety of ShapeFinder is to find differences in the blue versus green height. Right here, the difference is great. Guys, this right here is going to show a modification. Like this data will produce normalized shape values that are modified. This was a good scale factor. I'm happy with 0.4. Now the question is, if green is too high, or if it's too low, you can change this and go up right here for channel 2, right? You can change it to 0.5 maybe and try that. So we are done with that step. I'm going to pause now because I don't know how long we've been recording, and we'll resume in the next video.